Hello students, let us discuss Lewis structures in the chapter Chemical Bonding and Molecular Structure. Lewis structures, also called as electron dot structures or electron dot diagrams. These are the diagrams that show the bonding between the atoms of a molecule and the lone pairs of electron that may exist in the molecule. As we have already discussed the Lewis symbols, in which we are representing the dot around the symbol of the element. That is actually we are representing the valence electron present in that element. Here the Lewis structure, we are making the structure for molecule by representing the symbol of the atoms present in that molecule and along with the bond and the lone pairs. Lone pairs that we'll be going to discuss here. So this is actually the Lewis structures. So a Lewis structure can be drawn for any covalently bonded molecule as well as for a coordination compounds. Coordination compounds are the special type of compounds which we'll be going to discuss in 12th standard. So first let us recall what is covalent bond. Covalent bond formed by the mutual sharing of electrons between the atoms of the same or different element. Here, the electrons are shared between the atoms. That share pair of electron are represented by a bond. So, if there is a single bond, it means two electrons are involved here. So, we can say a single line means single bond, that means two electron. If we are making two lines, that represent the double bond which have total 1, 2, 3, 4 electrons. 4 electrons are involved in double bond. Triple line. When we make triple line, what it means? That is a triple bond. 3 lines means triple bond. So number of electron here 1, 2, 3, 4, 5, 6. 6 electrons. So the covalent bond either can be single, double or triple, and the number of electron involved in the single bond is 2. For the 2 lines, that is double bond 4. For triple bond it is 6. So that is called as electrons for the covalent bond. Now let us discuss an example. Water molecule. Water molecule, it is a Lewis structure for water molecule. What it represent? It's represent the atoms present in it. There are 3 atoms, that is 2 hydrogen atom and 1 oxygen atom. Their symbols are represented here and their valence electron, and here it is shown that there is a single covalent bond between 1 oxygen and hydrogen, and there is one more covalent bond, that is single covalent bond between the other hydrogen atom with the same oxygen atom. So this electron which is involved in the bond formation, that is called as shared pair of electron. Shared pair of electron that is involved in the bonding. So that electrons are also called as bonding electrons. That is also called a bonding electron. So let us find out here how many bonding electrons are there. Because here 2 electrons are there, that is a bonding electron. Here also 2 electrons are involved in the bond formation, that is shared pair of electron, that is also called as bonding electron. So here are there some electron around the oxygen which is not involved in the bonding, that is which is represented here in a dots. That is these 2 electrons, these 2 pairs of electrons are not involved in the bond formation. They are called as lone pairs. They are called as lone pair electrons. So what is lone pair? The electrons which does not involve in the bond formation but they are the valence electron are called as lone pairs. Now why it is called as pair? Because lone pair means this 2 electron together is called as lone pair, This is also lone pair. So pair means two. So two electron together we can call as pair. So what we can say that this is called as a lone pair of electron, and here the electrons which is involved in the bond formation, that pair is called as bond pair. So we come up with the two words here. Lone pair, that is the pair of electron which is not involving in the bond formation, but they are the valence electron, and the electron pair which is involved in the bond formation, that is a shared pair of electron, is called as bond pair. So let us discuss how we come up with the lone pair and bond pair to this molecule. So let us discuss the method how we make a Lewis structure. As we know that for water molecule there are two hydrogen atom and one oxygen atom. So the first method is count all the valence electrons present in this, that is two hydrogen atom, that is valence electron for hydrogen atom is 1. Because there are two hydrogen atom in this, so we can say that the number of valence electron is equal to 1 into 2, that is equal to 2. But here there is one oxygen atom also. So oxygen atom, the valence electron for oxygen atom, because it belongs to 16 group, the valence electron is 6, and here only single oxygen atom is there. Therefore 6 into 1, that is equal to 6. So when we make the sum of this one, we will be getting total valence electron, that is equal to 8 valence electron. So that is the first step. First we have to find out the total valence electron present in that molecule. That is, for two hydrogen atom, the valence electron is equal to 2, and for one oxygen atom, the valence electron is equal to 6. When you make the sum of this one, we will be getting 8 valence electron. That is the first step. Second step, determine the central atom in a molecule. So central atom here is the oxygen is the central atom. How we determine the central atom? Usually the single atom which is present in that molecule is the central atom. Here 2 hydrogen and 1 oxygen. So oxygen is the central atom. So the two terminal atoms are here. There are 2 hydrogen are the terminal atoms here. So we write it the 2 terminal hydrogen in this way. That is the second step. Determine the central atom and write down the terminal atoms. Third step, draw a single bond to the central atom. So the third step, we have to make single bond between the central atom to the terminal atom in this way. Fourth, put all the remaining valence electrons on the atom as lone pairs. 8 electrons. Start the counting from a terminal atom. So I am starting the counting from this hydrogen. So let us start this one. Here 8 electrons are there. First start with the bond. So here 1 electron. This is the second electron. As we know that the hydrogen gets stable by getting 2 electron, because only single shell is there in hydrogen. So with the 2 electron, hydrogen gets satisfied. Now next, 2 electron is over, third electron, fourth electron. 4 electron over. Now when you look at this hydrogen, now this hydrogen is also getting 2 electron. So both the hydrogen is satisfied. Now how much electron is left? Total 2 plus 2, 4 electron is over. But how much is there? Total 8 we have. So 4 electrons still left. So after giving to the terminal atoms, then the remaining electron should be given to the central atom. So here 4 electrons left. That electron will be given to the central atom. That is these 4 electrons. So what we can say that here the 2 hydrogen atom is satisfied because they are getting 2 electrons. What about the oxygen atom? In the oxygen atom, when you count the number of electrons surrounding to this, you can count that there are 8 electrons. How? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 electrons are there. So we can say that the oxygen is also stable. So this is the correct structure, that is the structure in which the two hydrogen atoms are terminal, and there is, we can say that there are two lone pairs. Two lone pairs it have, so we can say that it is a stable molecule. When we look at the structure, we can find out here there are two bond pairs and two lone pairs. How the bond pairs lone pair? Because here there are two bonds, so two bond pair, and there are two lone pairs. So we can say that there are two bond pair and two lone pairs. Now let us discuss for carbon dioxide. Lewis structure for carbon dioxide. Carbon dioxide having 3 atoms, that is 1 carbon and 2 oxygen. So which one will be the central atom here? That is carbon will be the central atom and the 2 oxygen will be writing on the terminal to it. Here find out the total number of valence electron present in this. That is here carbon atom, single carbon atom is present, that for 1, and here the valence electron for carbon is 4 because it belongs to the 14 group. 4 is the valence electron, so that is equal to 4. Oxygen, here 2 oxygens are there, so we have to take 2 into 6 is the valence electron for oxygen because it belongs to 16 group, so that is equal to 12. When you make the sum of this one, we'll get 16 valence electron. So total 16 valence electrons are there in carbon dioxide molecule. So let us do the first step. What is the first step? That is the total number of valence electron that we have find it out. Second step, what the second step say? Write the central atom in the center and the terminal atom in the terminal side. Third step, that is we have to keep single bond between these. So like this we can keep single bond. Now count the number of electrons. Total 16 electrons are there. So let us start the counting from this side. 1, 2. 2 electrons. I told you after giving to the bond, give the electrons first to the terminal atom. So 2 electron over, this is the third, 4, 5, 6, 7, 8. Now 8 electron, this oxygen is stable. That means this oxygen is satisfied. So 8 electrons over, this is the 9th electron, 10th, 11, 12, 13, 14, 15, 16. So 16 electron, what we have, the total number of electrons 16, that is over. So we have put 16 dots here, that means 16 electron over. Each dot represents the electron here, that is the valence electron. So 16 electron over. Check whether this oxygen is satisfied or not, that is this electron. So when you count the electrons, that is the dot surrounding to this oxygen, we can say there are 8 electrons. So that means this is stable. That means this oxygen is satisfied. So both the outer oxygen are satisfied. What about the carbon? Look at the carbon, because there is no further electrons left. So we are not keeping any dot to the central element, that is the central atom here. So when you count the number of electrons surrounding to the carbon, that is this much number of electron. When you count it, 1, 2, 3, 4. Only 4 electrons the carbon having. So we can say that the octet is not complete for the carbon. That means carbon is not satisfied. So we can say that the terminal atoms are satisfied here, but the carbon atom, the central atom, is not satisfied. Therefore, this is not the correct structure for this molecule. So this is, we are doing trial and error method. So this is not the correct method. So when in this case, after putting a single bond, if we are not getting the octet complete for all the atom, in that case we have to put a double bond. Now put double bond. So I am keeping double bond here. First put a double bond for one side. Now count it. So 16 electron, will start the counting. So we'll start the counting here. 1, 2, 3, 4, 5, 6, 7, 8. 8 electron satisfied. 1, 2, 3, 4, 5, 6, 7, 8. 8 electron satisfied. So both the terminal oxygen are satisfied. What about the central carbon atom? That is a central carbon atom. This much of electrons. When you count it, how much it is? The number of electron here surrounding to the carbon, that is 1, 2, 3, 4, 5, 6. Only 6 electron. So is it satisfied here? Because only getting 8 only the atom gets satisfied. So that means the two terminal atom are satisfied, but this is carbon is not satisfied. So we can say that this is not the correct structure for carbon dioxide. So in that case, what we can do, put a double bond on the both side. So when we put a double bond on the both the side, we'll be getting, we are doing the double bond here, both the side. Now count the electron in the same manner. So I'll start from here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we can say that here 8, here 8. So total 8 plus 8, 16. Therefore 16 electrons over. Now there is no further electron left. So terminal oxygen is satisfied. What about the carbon? Look at the carbon. These much electrons are for carbon. So count the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now the carbon is getting 8 electrons. So we can say that here all the atoms get satisfied by getting 8 electrons. That means complete, octet is complete. So we can say that this is the correct structure. And here we can say that the total number of 16 electrons are used here. So it is the correct structure. Look at here, total 16 electron, but these electrons, that is the electrons which is the bonded electrons are shared between the two atoms. So that electron is for both, that is to be calculated for both the atoms. So we can say that this is the correct structure for the correct Lewis structure for the carbon dioxide molecule. That means there are double bond between the carbon and oxygen. Therefore, there are two double bond here. Let us try for the structure carbon monoxide. Carbon monoxide, let us find out the total number of valence electron. That is a single carbon atom and 4 valence electrons. So 4 into 1 equal to 4. Oxygen, there is only single oxygen. Carbon monoxide, single oxygen. So 1 and 6 is the valence electron. So 6. So 6 plus 4, that is equal to 10 valence electron. So here total 10 valence electrons are there. So let us try this method. First, trial and error method. Put a single bond. Now 10 electrons we have. Start from here because there is no central atom. You can start from any side. So let us start here. 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electron. How much is remaining? From 10, 8 is over. Now 2 more remaining. So 9, 10. So 10 electron over. Let us find out whether the oxygen is satisfied here. How many number of electrons are surrounding to oxygen? That is 1, 2. Because these much electrons are involved for oxygen. So 1, 2, here 3, 4. Only 4 electrons this oxygen having. So what we can say that carbon is satisfied but oxygen is not satisfied. So cross it. This is not the correct structure. Now what we'll be doing after this putting single bond, the structure is not correct. So now let us put double bond. Again do in the same manner, that is count the 1, 2, 3, 4, 5, 6, 7, 8. Now this is satisfied. How much is remaining? From 10 electron, 8 electron over 2 is remaining. That goes to the oxygen. That is 9th electron, 10th electron. Now let us find out how many electrons are there surrounding to oxygen. So these much of electrons. Count here. 1, 2, 3, 4, 5, 6. 6 electron. So carbon is satisfied, oxygen is not satisfied. Why? Because it is 6. There should be 8. So we can say that this is not the correct structure. So what we'll be doing after keeping the double bond also, we are not getting the correct structure. Now keep triple bond. Do in the same manner, that is first 10 electrons, that is 1, 2, 3, 4, 5, 6, 7, 8. This carbon is getting 8 electrons satisfied. Now what about oxygen? After 8 electron, how many electrons left? 2 electrons is left. That I am keeping 9th electron, 10th electron here on the oxygen. Now let us count the number of electrons for oxygen. That means this much of electron. So that is equal to 1, 2, 3, 4, 5, 6, 7, 8. 8 electron. It is satisfied. Oxygen is satisfied. Carbon is satisfied. Why the carbon is satisfied here? Because this much of electron is carbon electron. That is 8 electron. So it is satisfied. So this is the correct structure for carbon monoxide. That is, this structure is the correct structure for carbon monoxide. Next, carbonate iron. Carbonate iron having single carbon and 3 oxygen. Let us find out total number of electron present in this. That is valence electron. Carbon, single carbon, the 4 valence electron, therefore equal to 4. Oxygen, 3 oxygen and 6 is the valence electron. So 3 into 6 is equal to 18. When you make the sum of this, we will be getting 22 valence electron. So total 22 valence electron, but here in the carbonate ion, 2 negative charge is there. So when there is a negative charge, you have to add that much of electron. 2 negative charge means we have to add 2 electrons. So that is equal to 24 electrons. So total 24 electrons are present in the carbonate ion. That is the valence electron. Which is the central atom here? C is the central atom because 3 oxygen and 1 carbon. I told you that the central atom, usually the single atom which is present in that molecule or the species, is taken as the central atom. So the terminal atoms, there are 3 oxygen, so that we are writing on the terminal side of the carbon. First, keep single bond between these. Now count the number of electrons. Total 24 electrons are there. So let us start from this side. 1, 2, 3, 4, 5, 6, 7, 8. 8 electron. 9, 10, 11, 12, 13, 14, 15, 16. 16 electron. So 8 here, this is also satisfied. 17, 18, 19, 20, 21, 22, 23, 24. So when you count here, 24 electron is over. So when you count, this oxygen is also satisfied. What about the carbon? When you count the number of electrons to the carbon, that is this electron, this 2, 3, 4, 5, 6. Carbon having only 6 electron. So oxygen are satisfied, but carbon is not satisfied. So this is not the correct structure. So what we'll be doing now, after keeping a single bond, if we are not getting the correct structure, keep a double bond between the carbon and oxygen, any one of the side. I'm keeping here double bond. Now you count in the same manner. So we'll start with the here, that is from double bond side. 1, 2, 3, 4, 5, 6, 7, 8. 8 electron. Here 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 8 electron here, 8 electron here. So 24 electrons finished. Now count the central atom. Central atom carbon having how many electrons? I told you the bonded electrons are, that is the shared pair of electron that you have to take for both carbon and oxygen. So 2 electron here, 3, 4, 5, 6, 7, 8. So total 8 electrons surrounding to the carbon. You can see there are 8 number of electrons. So we can say that the carbon is also satisfied. So we can say that this is the correct structure for which one? For the carbonate ion, that is like this. This is the correct structure for the carbonate ion because here it is a species in which there is negative charge. So we need to keep a negative charge over the structure. So we have to keep the negative charge, overall 2 negative charge, by keeping a bracket overall 2 negative charge. That is also most important here. After making the structure with lone pairs and bond pairs, you have to give overall charge to this by keeping a bracket on this way. So let us try with a positively charged ion, that is ammonium ion. Ammonium ion, do it in the same manner how we have done. Central atom is nitrogen. We are keeping the nitrogen in the center. Valence electron, 5 is the valence electron for nitrogen. Single nitrogen is there, so that is equal to 5. Hydrogen, 1 is the valence electron for hydrogen. 4 hydrogens are there, that is equal to 4. When you make the sum, 5 plus 4, that is equal to 9. But here there is one positive charge. So one positive charge means you have to remove one electron from this electron, that is from total electron. So 9 minus 1, that is equal to 8. So we can say that there are 8 electrons. Same way, keep a single bond and count the number of electrons. When you count the number of electrons, that is total 8 electrons we have. Total 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. All 8 electrons are used up. So you can check for hydrogen, get stable by 2. So you can see all the hydrogen have 2 electron. What about the nitrogen? When you count the number of electrons surrounding to nitrogen, that is also here it is 8. That means it is stable. So this is the correct structure, Lewis structure for ammonium ion. So here there will be no need of any double bond because after keeping the single bond itself, the structure is stable because of the electrons which is used, that is 2 is getting for each hydrogen and nitrogen is getting total 8. So it is stable. So similarly do for sulfate ion. For the sulfate ion, when you do in the same manner, you will be getting the structure like this. So here 2 negative charge, instead of keeping 2 negative charge overall bracket, you can write 2 negative charge, or you can keep the negative charge like this, how it is given, that is 2 negative charge it is kept on this oxygen. So when you try this one, you will be getting the structure of sulfate ion like this. Try nitrate ion. When you do in the same manner, you will be getting the structure. And nitrite ion, the Lewis structure is like this. So all of you try these 3 structures. Do it with a trial and error method for sulfate ion, nitrate ion and nitrite ion. Do it in the same manner how I done it here. Okay, so that is all about the Lewis structure. Have a nice day.